Hello and welcome to Math 200 Online Statistics at Cañada College. My name is Lapuz. In this video we will do a homework problem from section 7.3. It says to use technology in the given confidence level and the sample data to find the confidence interval for the population mean. Assume that the population does not exhibit a normal distribution. Because it does not exhibit a normal distribution, we will probably want to use the t distribution. We'll make note that we have a 95% confidence, n is equal to 51, x bar is 4.0, and s is 5.7. Let's open up our Google Sheets and put in this information. I have some of the information down. I think some of these might need some fixing. And let's double check. X bar is 4.0, S is 5.7, and N is 51. And we want a 95% confidence. Let's go ahead and get started with this. According to the formula, we want to find our margin of error, and the margin of error requires us to find our critical t-value. Our critical t-value will use a formula called TINV, so that's t inverse, and then we want the tails part of this, and so a whole 100% under the curve minus the 95 in the middle will give us the tails. Now that's a two-tail, and that's exactly what this particular program does. It looks for the two-tail area. So let's go ahead and type this in. I'll say equals TINV, and this is the inverse t. So inverse t distribution is what it's looking for. If we look at some of the details here, it's looking for the probability and degrees of freedom. So it only needs two things. The probability that it's looking for is the probability associated with the two-tailed t distribution. So again, 95% in the middle, so 1 minus 95% will give us our value. And for that, I'll just say 1 minus, and then I'll click on 95 here. You can put 0.95 if you want, or 95%. Either case will work. Next is the degrees of freedom, and the degrees of freedom is n minus 1, so we know that that's 50. That's an easy calculation in our heads, but I'm just going to click on this and minus 1, and that's going to give me 50. So my result is going to be 2.008, and I guess that's 2.01 if you round off to 2 decimal places. Instead of rounding off, we're just going to keep this value, and we're going to click on this cell whenever we need our critical t-value. Now the margin of error is going to be the critical t-value times the standard deviation s divided by the square root of n. So that's a formula that we're going to type in by saying equals, and the critical t-value is already here, so I'm going to click on this cell, and then I'll say times. The s is up here, 5.7. I'll click on that. Divided by, now the square root you actually have to type, so that's SQRT parentheses, and n is 51, but I'll just click on this number. I'll close the parentheses, and this is going to be my margin of error. Now that we have that, we're going to subtract the margin of error from x bar and add the margin of error to x bar to give us our upper and lower limits. Let's start with the lower bound. Again, we'll say equals. X bar is 4.0, but I'll just click on that cell minus the margin of error that we found. Enter. And then equals again, x bar. This time it's a plus margin of error. Enter. We generally want this rounded off to 2 decimal places or 1 decimal place, the same as the statistics that was given to us. And if we have original data set, then we would round off to 1 more decimal place than the original data set. So here we have 2.4 and 5.6. 2.4 and 5.6. A follow-up question here. Is the confidence interval affected by the fact that the data appear to be from a population that is not normally distributed? Well, we can say that that would normally be an issue, but I'm looking at the n value here. It's 51. That's well over 30, and 30 is usually our marker for being normally distributed, or something that starts getting close to normally distributed. So I would say it's not really affected by that, so no, because I think the sample size is large enough. So let's select this B for our answer. Alright, I hope that helps.